Before I get into the specifics of each type of joint, we'll just go over a few basics about joints and how to do selections, that sort of thing. So I'm going to select a joint from the assemble command. You can go down and select joint, or if it's pinned to your tabs, you can select it from there. I'm going to just go over simple joints. We have three different types of origin modes. Simple, which is just a point to a point between two faces, which lets you choose two faces and it will position it at a snap point between those two faces, or an intersection. But we're going to stick to simple for the moment. To select a joint, you're going to hover over various parts and you're going to get points that you can select, and you're going to get this joint origin. And the joint origin has, you can see a red, a green, and a blue, indicating the three axes. In my case right now, currently I have Y set to up, so green, this is the up direction of this joint, blue is this way, and red is this way. So when I select that, you can see my blue x-axis is pointing away from the part. So if I select that and go select another part, I can match it up. So I see when I select this point that it's going to join with that x-axis in the same way, so it'll line up correctly. If I were to select a point where the blue wasn't in that same orientation, like here, you can see blue, well, it's hard to tell blue from green sometimes. Blue, you'll see that this will join it in a sideways, versus if I select a point where the z-axis is up, like here, where now it'll go up. So that's how you can tell how it's going to orient when you select your joints. Let's go over just some things like offsets. I'm going to select this point, and then I'm going to go and select this point. And we see how it's not lined up in the center of the slot, of course, because there was nothing for me to choose in the middle of that slot. But if I hover over this, I can hold down my control key, and then I can go to the center of that slot and select it. And now it will go to the center of that slot. If I chose to connect it to the side here, you see it's not centered. So you can use offsets to move this over to where you want it. But the caution about using offsets is that if you modify this slot that I just put this pin into to make it wider, say, this will still only be offset by 0.125. It won't be in the center. So it's better to choose something that places it where you don't need offsets, if there's any chance that this part could be modified or reused in some way. You can use sketches. If I turn on sketches for this slot, you can use sketch points to align your joints, and that can help keep things oriented the way you want them. If you should modify the sketch, say if I choose this position and I want to choose it in a way where blue is up, now if I modify this slot to make it wider, this will stay at that point in the middle of that construction line geometry. If I don't like how it lined, like in this case, I can use the flip command to flip it over. Alternatively, I could have chosen the bottom of that slot or chosen it in a way where it oriented. That's not always possible. So what else would I cover here? If I undo that thing and it's not in the slot, again, I can use an offset. If it's possible to use a variable that would tell you what the depth of this is, that would be better than actually just moving it. You can set your offsets just by dragging as well. You can drag that down there, and over here you see an offset Z. It set that to 0.50. And that'll work, but it might not be very stable if you were to modify this part to, say, make it thinner or thicker or whatever. So one other thing to note is that when you're selecting your origin, if you hover over, there's a white side to this joint origin, and there's a yellow side. It's hard to see here. I'll show it over here on here. So if I hover over, you see that's yellow. So that is the back side of the joint, and the white side is the front side. So if I want this to be in the bottom of this slot, I'm going to select the white side here, and I'm going to go to the bottom of this slot and choose the white side here. I didn't get the right one. I don't want that because it's on the top. I need to do, I'm going to hover over the part, hold the control key, and go select this center, and now it'll be in the bottom of that slot. So one last thing I want to mention is that when you're setting up a joint that has motion, well, even if it doesn't have motion, the first joint you select, or the first component you select to join, will be the one that moves. And if it has motion, it's the one that will move when that motion is activated. So in this case, if I want this joint, this component to be the one that moves, if I were to put say a slider on it, I would have to choose it first and then choose its destination second. And then when you go to motion, it will be the one that moves. Okay. And I think that is about it for basics. So let's move on to individual joint types and how to set each one up. Okay, so let's do a quick overview of joint types, and then we'll get into individual joints and how to set each of those up. Okay, here I have several objects that I'll use to do a quick demonstration of the 7 joint types. First, we have a rigid. A rigid joint is going to lock 2 parts together so that they can't move. To demonstrate that, we will take this and we will join it to this, and it locks them together. If we preview the motion on that, they're stuck together. There's no degrees of freedom. This part cannot move anywhere. The next one we have is a Revolute. We'll choose Revolute, and on this one we can put these 2 parts together again in the same way. Put this right here, and now this has motion, and if we preview that, it'll rotate around the slot. Our next joint type is a slider. On a slider, rather than revolve, it moves in and out. So we've already seen how that works. Our next joint type is a cylindrical, which combines these two. If you look here under motion, there are 2 joints. There is a revolute and there is a slider. If we preview the rotation, we see that it rotates around the z-axis, and if we preview the slide, it slides on the z-axis. Later we'll see how we can use a motion link to tie these two joints together so that for every revolution the slide moves a certain distance, as in like a bolt. If you had a 1.5 millimeter bolt, pitch on a bolt, and you would want it to move 1.5 millimeters for every revolution, and we'll set that up in a motion link in a future part of this video. Our next type is a pin slot. For the pin slot, we'll use the slot here, and if we place this inside this pin slot, we see that it moves in, let's change that real quick just for a better view, and let's put it in the middle of this slot right there. Okay, let's move it up, and then when we preview the motion, it has just like a cylinder, it has a revolution. With a cylindrical, it slides and rotates on the same axis, whichever axis you choose. With a pin slot, the slide axis and the z-axis are different. If you choose for your rotate the x-axis, your slide axis choices are only going to be y and z. If you choose y-axis, your slide axes are only going to be x and z. You can't slide and rotate on the same axis with this, is the point. So if we choose z-axis for our rotate, then we have to choose a different axis for our slide. Next we have planar. On a planar, we can we want to select planes instead of specific spots, so delete both of these, and we're going to select this plane here instead, and we're going to choose this plane. I'm going to choose the center of it, and now if we preview the motion on this, it can rotate, but it'll stay on that plane. It can move in the z-axis, it can move in the y-axis, but it cannot move up or down. It can't move off of this plane. Okay, so if I say okay here and I try to drag this off, you see it won't drag off the top. Actually, I'd have to pin. Let's pin this so it can't move, and then we can see that we can't that's confusing. And let's get it on a plane. We can drag it this way, we can drag it this way, but we cannot drag it up and down this way. Okay, I hope that's clear. Our last joint type will be the ball joint type. So I'll select ball joint type, and I will select this ball and place it in this socket. I'll set some motion limits on this. 45 minus 45. 0. Set this to minus 45. 45. Set this to minus 45. 45. some rough joints. Okay, so if we now look at each one of these, basically it can move in 3 different axes within this socket in order to be able to just rotate freely. So it can rotate in that direction, it can rotate in that direction, and in this direction. If we click OK, we can go to Drive Joints and see better what that looks like by these 3 planes. So you see you've got this axis, you've got this axis, and you've got, where's the other one? If you move this one off, you see you gain this one off. And so now you've got an angular one as well. I don't know how clear that is, but you've got this axis, you got this axis and this axis, which allows it to rotate freely within the socket. Now we can go through each individual joint type with more specific details on setting each one up. First up is rigid joints. The rigid joint, as previously discussed, locks 2 pieces together with no degrees of freedom. We select the part. In this case, neither part's going to move, so which one you choose first and which one you choose second is not of significant relevance. So I'm going to choose this spot here. That's going to lock them together. If I go to preview motion, it shows that they're locked together. The blue part in this case is grounded. It's my grounded component, so you cannot drag on this in any way. It locks them together though. It does not lock them to the ground. If I go unground my grounded one, if I unground it, now I can drag the whole thing, but I cannot drag them apart. Next up is the Revolute joint. For the Revolute joint, I will choose, I'm choosing down at the base of this, but in the center of my spindle. And I'm going to place it here in the center of my hole. And if I go to motion and preview that, we see that it rotates while the base remains stationary. I should have put something on the base so you could see that it's stationary. Here we can use the alignments to rotate. Right now it rotates around the center, but we can make it rotate around another axis. I can drag it out there, and now if we go to our motion, we see that it rotates around that plane. So that's one way to use offsets here if you want to create something that orbits apart versus just rotates within its center. We can set motion limits on it so that it only rotates a certain degree. Here, if we wanted to rotate just halfway around this, we can say our minimum is 0 and our maximum is 180 degrees. And we can preview that, and it will just rotate back and forth within that range. We can choose which axis we're going to rotate on. In this case, it's not going to make much sense to rotate in this way, but if for some reason that's what you need, you can choose any one of the 3 axes. Slider joints are up next. The slider joint allows you to join two parts and have them have motion in a single axis. To join them, we're going to start a joint. We're going to go set our type to slider, and we're going to select, I'm going to select the end of my spindle. And for my second one, of special note is that the object you want to move is the one you select first. The one you want to be stationary, you select second. So those are joined there, and then if I preview motion, it'll slide along that axis in relation to the other part. I can set limits on this motion so that, say, my minimum is 0 and my maximum is 1/2 inch, the length of my spindle, 0.5. And now if I preview that, got to check that minimum first. Now if I preview that, it will only slide that 1/2 inch in and out. Lastly, we can choose any of the 3 axes for the slider to operate in. And of course, in this example, it only makes sense to slide in the Z-axis, but if your application requires it, you can slide in the Y-axis, or you can slide in the X-axis. I'll place it back on the Z-axis. And I think that's about it for the slider joint. We'll move on to cylindrical now. Next up are cylindrical joints. Cylindrical joints and all the remaining joints combine several joints into one joint. The cylindrical joint combines a slider joint with a revolute joint. The two joints can be coordinated so that, for instance, for every revolution, it will slide a certain distance using a motion link. We will demonstrate that in just a moment. So let's create a cylindrical joint by selecting cylindrical on the motion tab. We choose our positions. I want to join it on the end of my spindle into the center of my socket. And then I want to set limits. I want this to, I don't want to set any limits on my rotation. I want it to be able to rotate 360 degrees, but I'm going to set limits on my Z-axis. Right now it has no limits. I want to say my minimum is 0 and my maximum is 1/2 inch, 0.5. And I want it to rest at 0. Now if I preview my limits on my slide, preview my limits on my rotation, and say OK. And then if I go animate this joint, you see it will rotate in and out. While it's rotating, it slides in and out. Now if I want to control how far it slides for every revolution, I would put a motion link by selecting modify, assemble, motion link. I will select that cylindrical joint. A motion link is used to coordinate two joints. In this case, both joints are in a single joint. So I'm going to link with same joint by checking this box, and now it'll show me both the slider and the rotational joints. And what I'm going to do is I'm going to say I want, for every 360 degree turn of my rotation, I want it to move, let's say 1.5 millimeters. And now you see it's sped up. If I go drive the joints by right-clicking on cylindrical and drive joints, I can grab this rotational and turn it, and as I turn it, it will thread in at 1.5 millimeters for every rotation. Of particular note on a cylindrical is that the slide and the rotation are always on the same axes, which is in contrast to this pin slot, which is very similar, except that the rotation and the slide occur on different axes. Next up is the pin slot joint. The pin slot joint is very similar to the cylindrical joint, with the exception that the slider slides in a different axis than the rotation, whereas the cylindrical rotates and slides on the same axes. So when you select, say, the Z-axis for rotation on a pin slot, the slider axes available to you are the X and the Y, and etc. So to set this up, we're going to choose a pin slot type. I'm going to select my origin as the bottom of my spindle. I want the center of this surface. Oops. Yeah, no, I got it. And then I'm going to choose the center of this slot here. I'm going to choose, hover over the face and then go get that center and place it there. I'm going to go to my motion. I want my, if I preview, I'm sliding on that axis. I could choose to make my rotation or my slide on the y-axis. Of course, that wouldn't make any sense in this case. I could also choose to have my rotation be on the X, Y, or Z. So if I make it X, it's going to rotate on that axis instead. And in that case, then I can, for my slide, I can only choose Z or X. So then if I preview that, I get that. So I'm going to go back to my Z-axis for my rotation and set my X-axis as my slide. I'm going to set my minimum to 0 and my maximum to 2.75. Oops, I'm on the wrong. Let's not put any minimums. I need to be on the slider. So my minimum I want to be, I think I want it to be minus 2.75 divided by 2 to move it to that side. And for my maximum, I want it to be plus 2.75 divided by 2. Not quite. I think I need it to be 2.5. And 5. Now if I preview my motion, it's going to slide within my slot. And if I preview my rotation, it's going to rotate on the Z-axis. If I click OK and go animate my joint, it's going to rotate and slide along that axis. Next up are planar joints, which are used to limit motion to a single plane. The planar joint combines 3 joints into one in order to limit motion to one translational and one rotational. It will allow rotational along one axis with translation across the other 2. To set this up, we're going to go set our joint type to planar. We're going to choose this surface, and I'm going to choose this surface. I'm going to hold down the control key and select the center. Then I'm going to go to motion. You can only select the perpendicular axis. The slide axis is automatically selected when you choose this. So if I choose Z, my slide axes will be X and Y. If I choose X here, then my slide axis will be Z and Y. If I choose Y here, then my slide axis will be Z and X. So the only thing we choose here is which axis we want it to rotate on, and we're going to set that to Z, and then we'll preview that and we'll see that it rotates on that plane. And our first slide axis will be on the X, and our second one will be on the Y. If we click OK, we can see we pin this base. We're going to pin that so that the base doesn't move, and we can see now when we drag the top, we can, let's get it here where we can drag it right and left. We can drag it, it's confusing, let's get it here. We can drag it this way, but we cannot, need to get it back on top of it. It is actually on top of it, even though it doesn't look like it. We cannot drag it up and down. So it will only move on this plane that we defined here. We can limit motion. If we want to limit it only to, say, the x-axis, we can click on the y-axis joint, slide joint here, and set its motion minimums, and we see now it won't move. So if we say OK, now we can move this way, but we cannot move this way. The final joint type is the ball joint, so let's get into that. The ball joint combines 3 rotational joints into one in order to allow freedom of motion of a ball within a socket. If we go over to Fusion, they define it as it lets a component rotate around all 3 axes using a gimbal system, 3 nested rotations with no translations. The 3 rotations are called pitch, yaw, and roll. Let's go set it up. I've defined 3 components here: a stem, a ball, and a socket. I create the stems separately for a purpose we'll see in a little bit, and I'll explain that in a minute. But first thing I'm going to do is go join that stem to the socket using a rigid joint. I'm going to set it inside here and say OK. Now I've got my ball and stem. And then I'm going to create another joint, a ball joint. Go set this to ball. I'm going to select the center of that ball, because that's the piece that moves. And I'm going to choose the center of the socket and place it in there. And once we have that, then we can come over and we can grab this and roll it. We can move it around, but we have a problem in that you you see it can move past the edge of the socket. So to limit it so that it only stays within the socket, we need to create a contact set, which is the reason the stem is a separate component from the ball. We want to limit contact, so anytime there's contact between the stem and the socket, we want it to not be able to move. If we tried to set up a contact set between the ball and the socket, it doesn't work very well. So that's the reason for setting it up separately. So I'm going to go here and under Assemble and enable contact sets. Then I'm going to go to Assemble and I'm going to do a new contact set, and I'm going to select the stem and the socket and click OK. And now what we'll see is that when that stem comes in contact with the edge of the socket, it can't move past it. So that's how to set up a ball joint. Let's take a quick look at the other two origin modes that we did not cover earlier. So some final notes on joint origins. So far we've used only the simple joint type for the origin mode, simple. So we also have between two faces. So in this case I've created this tenon, and my slot here is my mortise, and I want to place this between these 2 points here. So for that I would use the this is going to be a rigid joint, and I'm going to choose the between two faces option for my origin mode, and then I'm going to select the 2 sides of my tenon, and I'm going to choose a snap point that is in the center right here. Then for my second component, I'm going to set to also between 2 faces. I'm going to choose the inside plane on the one side and the inside plane on the other side, and my snap point for that is going to be again the center of that grab the wrong one. Reselect my planes, and my snap point, it creates a plane right in the middle right there, and you see it joined those together between 2. So that's how you use between 2 planes. Then there's also the 2-edge intersection. So for that we'll go back and get rid of all these origins. We're going to use a simple for the first one, and we're going to choose the end of this ball joint here, and we're going to just choose that as our point we want to join to this block. And then for the second one we're going to choose a 2-edge intersection. And so what we're going to do is choose 2 surfaces, 2 points, and it's going to create an origin on that corner and position it in that manner. We can flip this if we so want. So that's how you use the 2-edge intersection. There are a couple of additional ways to join components, the first of which is as-built joints. Then we'll talk about rigid groups next after that. The as-built joint is another way to apply joints. In the case where your 3 components, or however many components you have, if you build them in relationship to each other, to where they're already placed where you want them to be, you can use an as-built joint, which will apply a joint to the item exactly where it is. So I'll go select an as-built joint off the Assemble menu, and I will select a component. In this case I'm going to do a rigid joint, and I'm going to join the tenon to the block, and I'm going to say okay. There's no motion on this one. You cannot move. And then I can apply another as-built joint to the cylinder on this side. Select this component, and this one I'm going to have move. So I'm going to choose a slider, and I'm going to choose this is my second component, and I'm going to choose a snap point right here. I want to slide on my x-axis, and I want to set minimum and maximum motion just like before. 1.25 and minus 1.25, and preview motion. Oops. Okay, make the first one minus and make the first one. Okay. Now preview motion. I'm going to click OK. And now if we grab this and move it around, you see they're all connected together. This one's a rigid joint, and this one, if I pin this so it can't move, I can't move the tenon because it's a rigid joint to this, but the pin slot, I can slide within that slot. So the as-built is pretty powerful in the case where you build your components already positioned to where you want them to be. Rigid groups are another easy way to connect components together if you don't need any motion on them. And one final type of joint, if you want to call it that, it won't show up under your joints, but we have what's called a rigid group. Now, if you've built or you have used the move command or whatever to put your parts together in such a way as you want them to remain, and they're not going to have any motion, you can use what's called a rigid group. With a rigid group, you can select multiple components, not just two, and lock them together. And now they're all locked together. They can't move independently. It's only a rigid type joint, but if you've got parts that don't move and you just need to lock them together, this is a very simple, easy way to apply a joint to them. And once these are connected, you can apply a further joint, say to this surface, to some other part that does have motion. One final topic is motion studies, which will allow us to analyze the relationships between our joints. Now that we have joints, we can do a motion study to put these joints to work, so we can see how they function together. So to create a motion study, we go to Assembly and select Motion Study. And then we want to select the joints that we want to animate. So I'll choose the cylindrical in this case. And the cylindrical has two joints, so you'll see over here in this dialog that it added the two joints, a slider and a rotate. So I'm going to turn off the cylindrical for a moment so I can just see, and each one is denoted by a color. So the slider is red. If I turn that off and turn on the cylindrical, it's denoted as blue. In this case, I've set this to move a ½ an inch. So what I want to do is I'm starting at 0, as indicated here, value 0 with my timeline at 0. If I take my timeline all the way to the right to 100, and if I go in here and click here, I can edit this line. If I scoot along this line to 100 and click, it'll bring up an edit. Now, if I don't get 100, I can set what step I want it to be here. But what I want to do is after 100, I want to be at 0.5 inches. then I'm going to click OK, and hit enter or click in the white space, and that'll preserve that. Then I'm going to turn on the cylindrical and turn off the other, and for the 100 steps, 100, it joined them up on me. And well, we're going to leave it alone for a minute. It automatically moved the cylindrical for me. We'll see if that's actually going to work. If I play my timeline, it does. Okay, so it automatically determined that to get to ½ inch, it had to turn 3,272.7 degrees to get to ½ inch. Sometimes you set those separately, especially if it's turning the wrong direction. You want to make this a negative number, but you have to play with it a little bit to be able to get it to edit them separately. But so now we can go down to the bottom line here, and we can say go forward and backward, which is a continuous loop. It'll go forward and backwards, or we can say just keep repeating the same thing over. In this case, it went all the way in. Now we want it to turn around and go all the way back out, so I'm going to choose back and forth and press play. And there you have it. It shows us. Now, just to you can also set your speed, so you can go super fast. You can slow it down. It's slowest speed. It's not super slow. So I'm going to press stop here. And just to make sure it's moving in, I'm going to hand move it slowly to see. So I've got the correct motion. When it goes clockwise, I want it to screw in, and when it goes counterclockwise, it wasn't. So if those weren't correct, then I'd want to set my cylindrical to go to negative number instead of positive number. I think that's about all I can say about motion studies. So once you're done, just click OK, and it'll be saved in your browser tree. And if you want to visit the motion again, you click here and click on edit and play. So that's your basic overview of joints in Fusion at this point in time anyway. Fusion is an ever-evolving thing, so and of course this doesn't cover every base. There's plenty more to learn about joints, but that's it for this basic introduction. That's it for joints in Fusion, or at least a basic introduction. Hope you found this useful. Take care. See you on the next one.